This example comes out of section 7.2, which is derivatives of sine and cosine functions. I want to talk first about the derivative of a sine function. If my function is y equals sine x, it looks something like this. We have at a couple of points earlier in the course said, well, what if you just had to sketch the derivative? Not do a perfect job of it, but roughly draw what this looks like. What we started with was said, well, there's a place here where the tangent would be 0, so let's use the same scale and put that 0 there. There's another place over here at 3 pi over 2, at negative pi over 2, at negative 3 pi over 2. And then we could look at the tangent lines and say, where are they sloping positive, where are they sloping negative, and you'd see that they go, from this 0, they'd go up for a little bit and then back down to 0, and then negative for a little bit, back up to 0, and the same kind of idea. And if you look at this graph, not that I did it extremely accurately, but it sure looks an awful lot like a cosine graph. And it turns out that is the case, that the derivative of sine x is actually cos x, which might not have been something you expected. It is relatively easy to prove with limits, and the fact that we know from previous that the limit as x goes to 0 of sine x over x equals 1, and we use that limit to just prove this by doing first principles. If you want to take a look at that, it's on page 308 of your book. You're not going to have to prove this on a test or a quiz or anything, but if you need something more than just a sketch. So let's do a couple of differentiate questions here. So let's take the derivative of y equals sine of 7x. Well, my derivative is going to be, again, it is a chain rule question, but a relatively simple one. Sine of something, the derivative is cosine of that. So cosine of 7x. But then I have to say times the derivative of the inside, which is times 7. You could put that 7 up front, but that would be adequate there. Now, this next one, I've got sine of something again. So the derivative is cosine of that same thing. And then times the derivative of the inside, but the derivative of the inside is just 1. So you're done. The next one, kind of a silly one, kx plus d. K and d are constants. So we've got cosine of kx plus d, and then times the derivative of the inside, which would just be times k. And so, again, use of the chain rule applies as it has in every other unit, and you've got some relatively simple examples there. Okay, so these last ones use, again, some chain rule stuff. We've got y prime for this one, sine of x to the 4, needs to be cos of x to the 4, and then times the derivative of the inside, which is 4x cubed. So, and normally we would write these as 4x cubed cos x to the 4, just so you don't confuse about what's being inside the cosine function. This next one is a little different because sine to the 4th x is the same thing as saying sine of x all in brackets to the power 4. So my derivative needs to be 4 times sine x cubed times the derivative of the inside, which is cos x. And you could write it that way, or you could write it 4 sine cubed x cos x, which is more common. Now this next one is a bit of a combination. We've got to the 4th power, so we need to say 4 times that to the 3rd power. Then we have to say times the derivative of sine, which is cosine of what was in there. But then we have to say times the derivative of what was in there, which is 3x squared. So notice it's a lot like peeling layers of an onion or something. You've got a function that's a 4th power function, so we take that derivative. We have a sine function, so we take that derivative. And we have a little polynomial function inside, so we take that derivative. And once we've peeled all the levels, we've got a derivative that we can use.